Okay, good morning, everybody. So today we are going to be starting into a new chapter and section, and that is Chapter 3, Section 1. We are going to discuss how to graph various forms of a line. So we have been talking about how to graph a slope-intercept form of a line, and we've been doing that for quite a while now. But now we're going to move into a different form called standard form. And standard form is a little different than slope intercept form, and it's graphed a little differently. So I'm going to show you how to do that. I'm going to show you how to identify what an x and y intercept are, which you should already know what a y-intercept is. So this shouldn't be too difficult. So let's get started. So the first thing I want to show you is what a graph looks like where the x and y-intercept are both being labeled. So you already should have known that this right here is the y-axis, and where the graph crosses that y-axis is called the y-intercept. Well, in a similar fashion, if you have a line and it crosses the x-axis, that point at which it crosses is called the x-intercept. Now, we do not have a fancy letter for the x-intercept. If you recall, the y-intercept letter is called B in slope-intercept form. The x-intercept does not have its own letter, so it just doesn't. So let's look at this. Now, this particular form of a line is a new form. So we have slope-intercept form already, and that is y equals mx plus b. And if you recall, this is your slope, and then this lowercase b is the y-intercept. Okay, so that's slope-intercept form, and we've been discussing graphing, doing all kinds of stuff with that form now for at least a couple weeks. We have another form of a line, and that is called standard form. And it says a linear equation written in the following form. And you can see it's ax plus by equals c. Now, I don't want you to get confused with this b right here. If you notice, that b is a capital B. It is not the same as the b in slope-intercept form. That's a lowercase b. And in math, if something's capitalized versus lowercase, that definitely matters. In this case, as you can see right here, it says that A, B, and C are integers. And if you recall what an integer is, it means they're numbers. So as an example of something in standard form, you could have an equation like 2x plus 3y equals 4. That would be an equation in standard form. You can see A would be 2, B would be 3, and C would be 4. A couple things to keep in mind about A, B, and C. They are integers. The lead coefficient, this first one right here, has to be greater than 0. It cannot be a negative number. A, B, and C are also not allowed to be fractions. So now if we look at this graph right here, it says identify the intercepts. And so you can see at the first, I wish they would have actually sorry about that. This light keeps going out on me. I wish they would have actually made them two different colors, but right there is the y-intercept, and you can see that that is crossing at 2 because it's 2 up from the origin. Over here, you can see that is called the x-intercept, and that particular one is crossing at -4. Okay, so notice something about this that's really important. It's for what we're going to do next, which is when you have a y, well, we'll start with the x. This x-intercept is -4, and you can see right there that they said the x-intercept is -4. But what I want you to notice is when we are on the x-axis, which is the horizontal line, the ordered pair has a -4 for the x value, but the y value is 0. Because we did not go up or down from the origin. We simply went to one side. So anywhere on the x-axis, if you have a point, the y value will be 0 right there. Now, the same holds true for a y-intercept. If you look over here, the y-intercept is 2, right? So it's crossing the y-axis at 2. But if you look at the actual ordered pair, the 0 is in for the x value, because from the origin we simply went up. We did not go left or right. So you've got to keep in mind with ordered pairs are two numbers. It's how far left and right, and then how far up and down. So if you don't go left or right, it's going to be 0. And so in general terms, what I want you to see on this slide, and I'm going to erase all the markings that I did on here, is I want you to see that when you have an x-intercept, the y value of an x-intercept is 0. When you have a y-intercept, the x value of an ordered pair is 0. And this is important for one of the things that we're going to do here in a little bit. So this says simply identify the intercepts. So I want you to write them as an ordered pair. So if I look at this first graph, you can see right here, it is crossing right at 20. But for that point right there at 20, the ordered pair, we simply went to the right 20, but we did not go up or down to get to that point. So the ordered pair for the x-intercept would be 20, 0. Now, in similar fashion, if I go right here, and you can see that the y-intercept, it's crossing at 30. But from the origin, we simply went up to 30. We did not go left or right. So the ordered pair for this would be 0, 30. Now, for the next one, part B, it's going to be the same. You can see right here is the x-intercept, right there is the y-intercept. And so the x-intercept, we just went to the right 4. We did not go up or down. So it is 4, 0. And for the y-intercept, we went up to 200, but we did not go left or right. Now, don't forget, ordered pairs are always x and then y. So x is right and left. The y's are up and down. So remember, it's opposite of slope. So for the ordered pair for the y-intercept, it's going to be 0, 200. And so now, well, let's go back here for a second. If you notice, the x-intercepts are going to have a 0 for y. See that? The y-intercepts are going to have a 0 for x. And we're going to use that to identify the x and y intercepts in the next two tables. So if you look right here, we've got a 0 for x. So if we have a 0 for x, this is the y-intercept. Looking through the table, I can see I have a 0 right there for y. And because I have a 0 for y, this is going to be the x-intercept. Okay, and looking in the next table, same thing. Here we have, this will be our x and this is our y. There's our 0 for the x, there's our 0 for the y. So if the x is 0, it's the y-intercept. If the y is 0, it's the x-intercept. Okay, so now why am I showing you all this? Well, here's why. We want to graph something in standard form. Now, up until now, if I asked you to graph this, you would move the 2x to the other side, and then you would divide everything by 4 to get y by itself. I'm going to show you an easier way once you catch on to this, okay? And that easier way is to put in 0 for x and solve for y, and then put in 0 for y and solve for x. And this at first will seem like it's longer, but once you catch on, it's much, much faster. So I'm going to start out with this equation, 2 times 0 plus 4y equals 16. So you can see 2 times 0 goes away. I'm simply left with 4y equals 16. And when I divide both sides by 4, I get y equals 4. Okay. Now what I'm going to do now is I'm going to go to 4 on the y-axis and I'm going to put a dot right there. That is the y-intercept. Okay. Now I'm going to do and I'm going to put a 0 in for y. So first I put the 0 in for the x. Now I'm putting the 0 in for the y. You can see 4 times 0 is 0. Goes away. I'm left with 2x equals 16. I'm going to divide both sides by 2, and I get x equals 8. So now I'm going to go to 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put a dot right there. That is my x-intercept. And I'm going to simply draw a straight line. And I've graphed my line. Okay. Now I know that seemed like probably a little bit more work than if you just would have taken in the original equation and solved for y. But I'm going to show you how this actually is faster. Okay. And this is what I would do. We're going to do another one of these, but I'm going to show you the quick way that I do this first. Okay. So the quick way that I do this is I simply just scribble this out, right? 8y equals negative 24. So when I solve that, I get y equals negative 3. See how I did that? 8y equals negative 24. Just divide both sides by 8. I get y equals negative 3. Now I'm going to do the same thing, but I'm going to scribble out this. I can see that there's negative 4x equals negative 24. So when I divide both sides by negative 4, I get x equals 6. Okay, so now this gives me the 2 points that I need to plot to draw my line. I'm going to go down 3 on the y-axis. I'm going to put a dot at negative 3. And on the x-axis, I'm going to put a dot at 6. And then I'm going to draw my line right through there. And then I got my line. Okay, now that was the fast way. Which was just scribble out each of the terms and you can get your points. That's the way I do it. That's the way I would like you guys to eventually do it. But let me show you what I showed you in the last one. So the first thing you're going to do is you're going to put in 0. And you can see that negative 4 times 0 is 0. That's why that cancels out. So I'm kind of skipping over just substituting the 0 part in. Now I have 8y equals negative 24. That was a bad 2, sorry. Then I divide both sides by 8. And y equals negative 3. And that's what I said before. That's why we put our dot down here at negative 3. Okay? Now I'm going to do the same thing, but I'm going to put a 0 in for the y. So negative 4x equals negative 24. Divide by negative 4. X equals 6. And you can see this one went right there. This one goes on the x-axis at 6. And then once you have 2 points, you can draw your line. Okay, so I'm going to do one more of these. Again, I can show you the quick way or I'll show you the long way also just to show you. So, when we substitute zeros in, it just cancels things out. So if you look, I just get rid of this, right? So negative 7y equals 21. That means when you divide both sides by negative 7, y equals negative 3. Okay, now I'm going to do this. This time I'm going to scratch out this one. You can see that negative 3x equals 21. And so when I divide both sides by negative 3, I get x equals negative 7. Okay, so I've got my 2 dots. X equals negative 7. Y equals negative 3. And now I can simply draw my line through the both points. And I've got my graph. Okay, you guys see how to do that? Hopefully the quick way makes more sense because, if you would rather substitute the 0 in and do all the work, that's perfectly fine. That's okay. And this one as well. You can see how I did that there. But these last two, I'm going to do the quick way just to show you. Okay, so this is the last one right here. Once again, I'm going to scribble out the first term. And so you can see I have negative 3y equals negative 12. So if I were to solve that by dividing both sides by negative 3, I get y equals 4. Okay. Now I'm going to do the same thing, but I'm going to scribble out the second term. And you can see if I were to solve that, I have 4x equals negative 12, which means x is negative 3. Okay. Once I have those two numbers, I can put a dot on the x-axis at negative 3. I can put a dot on the y-axis at 4. And then I can draw my line just like that. And I've got my graph. And that's that. So hopefully that made sense. If you guys have any questions, feel free to reach out to me in my email. Have a great day.